All right, guys, today we are at the beginning of chapter 10. This chapter is all about circles. Last chapter was all about triangles. Now we're just on to a new shape, everybody. So today we're going to talk about a lot of different parts of a circle. There's like every beginning of every chapter, there's a lot of vocabulary today. Nothing too intense really as far as work goes. It's going to be identifying different parts of a circle and maybe a little flashback to using some Pythagorean theorem. So get ready for it. A few things we got to fill in on the note sheet. Here we go. A circle is the set of all points in a plane that are equidistant from a given point called the center. So, of course, you can see from the very lovely picture here, they've got the center labeled for you. All the points around it, of course, are equidistant from that. Now, radius. The distance, this is what I think of it, is really the segment from the center to a point on the circle. So, let's fill in our definition for radius. And again, you can see it on the picture. They've got it labeled, or in mine it's on red, of course. I wish we had color copy machines. From the center to an edge. Now there's an infinite amount of radii, plural radius. That's just one of them. From the center to the edge, there's another radius, another radius, another radius. I could draw these all day long. So don't get hung up on the fact there's just the one in the picture. Okay, diameter. Let's fill that in on our note sheets. We got to write in the definition here. A segment from one point on a circle to another point through the center twice as long as the radius. Now I know that sounds super wordy. You all know what the diameter is. It goes through the center and it goes from end to end. That's what the diameter is. Now again, there's an infinite amount of diameters you could draw in the picture. That's one example. So through the center, edge to edge, there's another diameter, another diameter, another diameter. I could draw these all day long. See that. But just don't get hung up on the specific one on the picture. There's an infinite amount of those. Okay, some new vocabulary probably for you. Next up we're going to talk about is a chord. A chord of a circle is a segment that has its endpoints on the circle. Now, chord, you can see it's in red here. Endpoints, because it is a segment on the circle. A diameter is a special type of a chord, because its diameter is a segment, but it goes through the center. So diameter is a chord that contains the center of the circle, just for knowledge's sake. Okay, secant. A secant is a line. So chord is a segment, secant is a line that intersects the circle in exactly 2 points. Every secant forms a chord. A secant that goes through the center of the circle forms a diameter. So let's take a look at the picture here and talk about all this different vocabulary. I'm just going to move it up here a little bit. So secant, let's start with that. A secant is a line, arrows on both sides, and of course it intersects the circle 2 points. Now, every secant, it says, forms a chord, because we have a chord between these 2 endpoints. So if I needed to list a chord, of course, segment AB. If I wanted to list the secant, line AB. Little nitpicky details, as you know, the love of geometry. Okay, next up, tangent. Tangent can be just about anything here. A line, a ray, a segment is tangent to a circle if it intersects the circle in exactly 1 point. 1 point. So you can see down here they drew this red line. It is touching the circle right there in 1 point. And of course we call that point of tangency. So it can be a line, it can be a ray, it can be a segment, any of it. Doesn't matter. Touches the circle in 1 point only. A lot of vocabulary, we're just starting, so as always, I would keep your notes handy as you're working on the homework. I don't expect you to have it all memorized right away. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. All right, let's start with letter A. Now, the symbols are key. On letter A, we have a segment symbol. So segment AC. So a segment that starts at the center and goes through the edge, of course. We all know that one. Radius. Segment, letter B, segment AB. So this segment goes through the center and goes from one end to the other end. That, of course, we all know it. That's just a diameter. So don't overthink radius and diameter. You know those. Those have not changed. Okay, C. Ray, D, E. So DE, ray DE touches the circle in one point. If it touches, it's tangent. TT, touches tangent. And then the last one, letter D, line AE. So this line. So the line touches the circle in 2 points. If we touch in 2 points, that is a secant. So just identifying the different pieces, the different vocabulary, the different parts of the circle. Okay, coming up next. Just look at this. This is kind of common sense in a way. So let's talk about coplanar circles and common tangents. In a plane, 2 circles can intersect in 2 points. That's the first picture, the blue one. 1 point, that's the middle picture, the red, or no points. That's the right picture, the green ones. Coplanar circles that intersect in 1 point are called tangent circles. Remember, you intersect in 1 point, it's tangent. Coplanar circles have a common center are called concentric circles. So you can see the picture over here on the very right-hand side. This is our concentric circles. They have the same center, just different size circles. All right, a line or a segment, of course, that is tangent to 2 coplanar circle, common tangent. Common internal tangent intersects the segment that joins the centers of the 2 circles. Common external tangent does not intersect the segment of the 2 circles. So just some different things to talk about when you look at how 2 circles could intersect. All right, next up. We got to fill a little bit in on the notes here, and this is key for our next upcoming problems. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius, another blank you got to fill in, of the circle at its endpoint on the circle. Now, perpendicular, we all know it, makes right angles. You can see in the picture over to the right side, they have the right angle symbol. If it's perpendicular, it's tangent. We have to know that it's perpendicular for it to be tangent, of course. So that is the next thing we are going to test. In the diagram, segment PT, so that's this one, is a radius of circle P. Yes, I agree with that, from the center to the edge. Is ST, segment ST, I'm going to do that guy in green, is that tangent to circle P? So the question we all want to know if it's tangent, and I'm not saying this is or not, I'm going to draw a dash because I'm not sure, is this a right angle? Question mark. That is what we need to try to figure out. Is it right? Is it a right triangle? Now we are back to the good old Pythagorean theorem from the last chapter. We all know Pythagorean theorem. So we're going to test it. Our biggest side, of course, our hypotenuse is 37, so that's going to be our C. Now, I'm going to separate it because I don't know if they're equal. I'm testing it. I want to know, does 12 squared plus the other side squared, does that, in fact, actually equal 37 squared? So now we're to the calculator. The left side, of course, we can just punch in. I got 1,369. 37 squared, I got the same exact thing, which does make it right. So now I am going to actually fill in with a solid. That is the right angle. I'm going to cross off my question mark. So if it's right, that means, yes, it is tangent. If it wasn't right, it is not tangent. So just like the last chapter, we're just testing with the old Pythagorean theorem. Okay, in the diagram, B is a point of tangency to the radius. So they are telling us it's tangent. So it's telling me we know this is a right triangle, that is a right angle. Find the radius of C. So again, I'm doing Pythagorean theorem. So let's set it up. Side squared, I'm going to start with the 80 squared, plus my other side of the triangle, which is the radius, I don't know, r squared. Now here's where it gets dicey. Your hypotenuse. Hypotenuse, of course, is the side across from the right angle. So it's the 50 and the r combined. So I have to add 50 and r together. So that's going to take us into some algebra solving. So let's get ready for that. 80 squared, type that in your calculator. Maybe you knew that one. Now, back to algebra 1. We have to write out this binomial, 2 terms, and do a full distribution or FOIL on it. So I'm going to start multiplying or FOILing the right-hand side. 50 times 50, we need your calculator for that, plus 50r, plus 50r, plus r squared. Whew, got a whole lot of terms here, people. Now, algebra, let's solve it. I see that r squared on either side, so plus r squared and plus r squared are going to cancel, so that's kind of nice. So the left-hand side, I just have my 6,400. The right-hand side, I've got my 2,500, and these are like terms. I combine them. 50r plus 50r, 100r. Okay, I'm going to get rid of the 2,500. We're just going to subtract that off. So of course, type that in your calculator or do it in your head, either one. It is 3,900. And to get r by itself, we divide off 100. So 3,900 divided by 100, 39. So yes, there are a couple of these on the homework. Please be careful on that hypotenuse because you have to add the 50 and the r, and then it turns into a lot of Algebra 1 review where you have to FOIL or distribute that all the way together. All right, last thing we're going to look at today. Tangent segments, tangent touches the circle, from a common external point, so that would be point S, are congruent. So what it's saying is from S to R is congruent S to T. So if you have two tangents touching the circle in one point, coming from an external point, this is my external point, those two segments are going to be congruent. Well, that seems easy enough. So RS is tangent to circle C, and RT, segment RT, is also tangent. So if they're both tangent, congruent. Super easy. Find the value of x, we're going to set them equal. So 28 equals 3x plus 4. Then of course I'm just going to subtract 4 from each side. And last but not least, divide by 3. Do that in your heads. All right, there you have it. A lot of vocabulary, some simple solving for x, and like I said, be careful on this problem, on that hypotenuse, that you add up both pieces, and you do have a lot of algebra to do. All right, enjoy. Obviously, you have some homework. I need the work on separate paper or do it on the back side, but the key is I need work for these, not the vocab, obviously. All right, have a great day.